Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Bradsher reaction. Let's see the statement. Acid catalyzed conversion of ortho-acyl aryl methanes into anthracene derivatives. According to the statement, this reaction is useful for the synthesis of anthracene derivatives. So what will be the reactant here? Ortho-acyl. If you talk about ortho-acyl, means we should have a benzene ring or not? Benzene ring should have the acyl group, C double bond O R. Okay, this is connected to aryl methane. Methane means CH4. Aryl means we should replace the hydrogens with benzene. Aryl methane. This group will be connected to what? This acyl one, CH2 benzene ring. So according to this benzene ring, this is the acyl position, acyl one. Both are ortho to each other, and this one is aryl methane. So these type of reactants will be converted into the corresponding anthracene derivatives. Let's see the equation. See this one. C double bond O R CH2. The reagent condition is HBr in acetic acid produces anthracene derivative. Mechanism is very simple. HBr in acetic acid initially produces H plus ions in the solution or not. So H plus ions means we need to have an electron rich center in the reactant. Let's see our reactant is this one or not. Ortho-acyl aryl methane. Here we have oxygen contains lone pair of electron. The lone pair of electron donated to H plus, thereby it produces OH bond. Once it is donated, its electron pair means it is losing electrons or not. So positive charge will be created. So in order to neutralize this positive charge, what is happening? The pi bonding electrons are moving towards the oxygen. Thereby this carbon will take positive charge or not. So in order to neutralize this positive charge, the pi bonding electrons from the benzene ring shifting towards this carbon, thereby creating a carbon-carbon single bond and producing a cyclic compound. So carbon-carbon bond formation takes place. Once these pi bonding electrons shifted towards this side, means here electropositivity will be developed or not. So electron deficiency is developed, positive charge. So here it is a aromatic one or not. Now the aromaticity is disturbed or not. So in order to retain its aromatic character, what happens? The hydrogen removed in the form of H plus ion by leaving a minus charge here. Thereby plus and minus forms a pi bond here like this. So again oxygen lone pairs takes H plus ion. OH2 plus formation takes place. To neutralize this oxygen, these bonding electrons moving towards the oxygen, thereby H2O is removed. Again positive center is developed. These pi bonding electrons forming a pi bond between these two carbons to fulfill the valency of this particular carbon. Thereby positive charge creation takes place here. In order to neutralize the valency here, the hydrogen is forming a pi bond like this and removed in the form of H plus. Thereby we will come up with the corresponding anthracene derivative. Okay, let's see the example. If you see this moiety, consider this one. It is the benzene ring or not? Benzene ring is having acyl group or not? At the ortho position we are having CH2 benzene. So aryl methane. So it will be involving in which reaction? Bradsher reaction. So it can produces this kind of compound. So while writing the final product, you need to have in your mind that, see, whatever the R group which is the part of the acyl one, that should be the substituent at the center carbon, center circle or center cycle we can say. Okay, center ring we can say. Okay, the R group should be a substituent at the center ring. So simply see, In this example, what we are witnessing, CH3 resembles R or not? So the CH3 should be attached to the center ring or not? CH3 is attached to the center ring. So accordingly, these two groups will be arranged. Okay, this thing you need to have in your mind. So similarly, this reaction not only applicable to the anthracene derivatives, similar kind of moieties can also be developed, aromatic moieties. Let's take an example. See this, here it is a compound, it is a compound which is having two thiophene rings, right? Both are aromatic in nature or not? So initially what the people have done, acetylation phenomena. So simply what happened, at this position, acyl group is added, C double bond O CH3. Now see, assume that it is a benzene ring, C double bond O CH3 ortho position, CH2 aryl group is there. So that's why this reaction can be subjected to Bradsher reaction. So in between the two thiophene rings, what we will observe? A benzene ring. Okay, a benzene ring is observed, and the C double bond O should be the attachment of this benzene. Okay, remaining here also Cl is there, remaining is okay. Okay, so in this way we can convert the ortho-acyl aryl methanes into the corresponding anthracene derivatives. Thank you.